Okay, 6.2, part 2, example 3. All right, before we even begin going ahead and graphing all this, we're going to take a look at our equation and see what we can get out of it before plugging in some random points. All right, so remember that our h value, when it's in the minus form, that and the k value, that's our vertex. So if we look at what we've been given right now, we've been given x plus 4, which remember is really like saying x minus a negative 4. That's another way to look at this problem. So that means that our vertex is negative 4, 1. All right, so right there, I can go ahead and I can graph that point, and I can put in negative 4, 1 for my vertex. All right, other things that I can tell, well, if my vertex is negative 4, 1, I know that my axis of symmetry is going to be negative 4. That was horrible. Let's make that a straight line. There we go. All right, so my axis of symmetry is x equals negative 4. All right, so I've got that part. Now, the other thing is, remember that this a value right here tells us some information as well. Because it's negative, we know that it's going to open downwards. It's going to be flipped upside down. So that means that if we flip it upside down, then we're going to have a maximum. And our maximum is the vertex. So remember, the vertex is either the maximum or the minimum. Depends on where it opens up. All right, so we know that that's the highest point. Well, if that's going to be the highest point, I can go ahead and say that my range is going to be from negative infinity up until that point, which is up to a 1 bracket, because it goes up to that. And my domain is always all real numbers for those, right? And because of the 1/2, I know that since my a value, the absolute value is less than 1, it means that I'm going to make it flatter, because again, the absolute value is less than 1, it's 1/2. So I was able to fill out all that information without even graphing it and just looking at those characteristics. Now, to go ahead and just complete the graph, what I'm going to do is I'm going to start with my vertex, and I'm going to make that my middle point. Because remember, I'm going to pick points on either side of it. So that's kind of in my center, negative 4, 1. I'm going to pick negative 5 and negative 6 and negative 3 and negative 2. And I'm going to go ahead and I would plug those into the equation. Right, so take a minute and just plug those in and see what you get, and we'll jump back in together. Okay, here are the values that you should have gotten. All right, and so we can go in and graph those, negative 5 and 1/2, negative 6 here. And we can see by that shape how it's becoming wider. Now for the x-intercepts, again, we're going to kind of skip this for right now because there's a better form for x-intercepts. But for our y-intercept, remember y-intercept is when x is 0. So I can just plug in 0 for my x value, and I can calculate that, and I will end up getting negative 7. And for me, that does work out. It is on the graph. So it kind of helps just build my shape a little bit more. And I'm able to graph from there. Okay? All right, so, let me plug it in here too. So we were able to get most of our information without even having to graph it, and that's the benefit of these different forms and how they're able to tell you that information. So we're going to take a look. Now, this is referring to example 4 in your book, but I'm going to choose a different one. I wanted to use just different numbers to help us out. So the function rule that we're going to do is f of x is x squared minus 4x and minus 2. I think that's the one I chose. Now notice this is in standard form, okay? So when it's in standard form, remember there's a few things we can tell from standard form. We already see that the a value is 1, so we know that it's going to be the same. It's going to be the same like shape. It's also positive, so we know it's going to open up. And from this form, if I plug in 0, I know that my y-intercept is negative 2. Okay? So, but what we want to do is to help us with the graphing part too, is to make sure to let's see, how do we convert this into vertex form? Well, vertex form is really just completing the square. So I'm going to do my work off to the side here just because this is a little bit tight for me with my writing pen. So the way I want you to think about this is I'm going to replace this and I'm going to make it look like an equation. And I'm going to set it just equal to 0 to show like whatever we do to one side, we got to do the other. But we're not actually solving. Okay, that's what I need you to understand. So I've got x squared minus 4x minus 2 equals 0, right? If we were doing the complete the squared method and solving this way, this is what we would do. So we're going to do the same kind of setup, but learn how to rewrite it this way. So the first thing that I'm going to do is I'm going to bring that to the other side. Okay. So it becomes a positive 2. And then remember, I want to make this a perfect square. So this value, this new c value, is going to be half of my b value. So half of 4 is 2. And I'm going to square it. So it's going to be positive 4. Well, if I add 4 here, I have to add 4 here. Okay? And then now that I have that, I can do x minus 2. I'm going to rewrite this as a perfect square, factored perfect square. And I have it equal to 6. Well, so now this is like where I would go about if I wanted to find the steps, and I would solve from there. But that's not what I want right now. What I want to do is I want to turn this back into just a function. So all I'm going to do is I'm going to bring this 6 back over to this side. So I'm going to minus 6. And now it's back to being set equal to 0. So this is just that function rule. So I've just gone ahead and now essentially, okay, equals, oh, there we go. All right, I've just converted, I'm going through the steps, and now it is in vertex form. So now that I have it in vertex form, I can identify the parts and I can see how it moves on the graph. Okay, so here, okay, this here, my vertex, right? We can get our vertex from there to negative 6, right? And we can see that to 2 and then go down 6. There. Okay. We can also graph our y-intercept, 0, negative 2. All right. Notice that the a value, which we already talked about, it already is opening up. So, and that means we're going to have a minimum. So our vertex is our minimum. And my axis of symmetry is the x value. So it's 2. So that means it's going to highlight that. Straight lines and oh, that was the hardest straight line again. Okay. And from there, we can also talk about, well, my domain is still going to be all real numbers. My range, this is my lowest point, so the lowest I go is negative 6, which is included, and I go up into infinity. So again, we're not going to worry about x-intercepts for now. All right, but if I wanted to graph, so because this doesn't have a multiplier, it's actually really easy to go ahead and do the graph because there was no stretching, like making it flat or stretching it out. So we can just do the movements. This tells me to move to the right 2 places, and this tells me to go down. And if we start at the vertex, notice that's what we did. We went to the right 2 places to 2, and we went down 6 places to 6. And we're going to do that with every other point. So go down over 2, 1, 2, 3, 4, 5, 6. And I know it's going to have the same point on the other side of the axis of symmetry. I'm going to do the same thing here. 1, 2, and down 6. There's 4, 5, 6. And that's my y-intercept. And so I know that's going to be right there. So I didn't even need to make a table of values in order to graph it. All right. Okay, so hopefully you're catching on by now. Okay, so for example 5, again, we're going to actually follow along with this one. This one is directly from your book. This one, I thought this one was easy enough numbers, so we're good to go with that. I want to show you how to convert when your A value is not 1. It becomes a little trickier and with the completing the square method, but it's still doable. Don't panic. All right, but before we even begin, let's go ahead and just figure out what do we know. All right, well, we can see that the A value is negative, right? So that means that we're going to open down. We also see that it's a 3, so that's going to make it steeper because the absolute value is greater than 1. And so because it's going to open down, right, looks like this, that means that we're going to have a maximum and that depends on what our vertex is. We don't know what it is. But then also from this form, remember, we can also get the y-intercept. We plug in 0 and we get out 1. All right, so now let's go ahead and take a look at how we're going to go ahead and use what we know about the completing the square to help us out. So I'm going to go ahead and make it into an equation, and like I'm going to solve for it. So the first thing we do is going to go ahead and, now normally what we would do before was we divide everything by that 3. We're going to show you a shortcut here. All right, so we bring that 1 to the other side. Now, yes, we do need to factor out that 3. We need our leading coefficient to be a 1. So we're going to go ahead and do that on this side. Now, we're not getting rid of it. We're just factoring it out. And that's an important difference, okay? Because now we want to take what's inside here, right? I didn't change anything. I just am factoring it. So now what I want to do is I want to make this, what I factored out, a perfect square. So it's going to make our lives a little bit easier because we don't have to worry about fractions. So, all right, well, what's half of 2? 1. And 1 squared is positive 1. Okay, well, on this side, we already had negative 1. And you might be thinking, oh, I just have to add 1 to this side because I added 1 to this side. Almost. We didn't add 1 to this side. What happens, remember, look at what happens here, is if I were to distribute this 3, that makes it negative 3x squared. And this becomes positive 6x. But remember, I got this negative 3 times a positive 1. So what am I really doing? I'm really adding a negative 3 to this both side. So even though it looks like I added a 1 because there's that multiplier out there, I really added a negative 3. So I've got to do the same thing to both sides there. So now I have negative 3, and now I'm going to take this guy and write it as a perfect square, x minus 1 squared equals negative 4. We're going to bring this guy right here back to the other side, and we will now have it in vertex form. And from there, we can get our vertex. We can see that our vertex is 1 and 4. If we go to graph that, 1 and 4. All right, and then that also means that our axis of symmetry is x equals 1. Our domain is still the same. And remember, our range, we're opening down. Our graph is opening down. So that's going to be the highest point. So the highest point, we're going to go from negative infinity, and we're going to reach the highest is a 4. And we're not going to worry about the x-intercepts. And that means that my vertex is 1 and 4. All right, and so from there, now I've got a good idea of what points I want to choose to graph. So go ahead and stop here. I'm going to go ahead and plug in some points based off of my vertex. So 1 and 4, I'm going to plug 0 and negative 1, and I'm going to plug in 2 and 3. And press play in just a second to see the final results. Okay, here's what your graph should have looked like. Again, based off of the vertex. Pick 2 points smaller, 2 points bigger, and it doesn't matter which one you plug it into, you can still get your outcomes there, and that's what your graph should have looked like. All right, I hope to see you guys tomorrow. Take care.